Good afternoon, or good morning, or middle of the night, whatever time of day it might be for you. Um, this is a lecture to uh, replace the class that I canceled on Monday. I felt that I was getting enough information about the class population that it would simply be easier to offer this particular material in an asynchronous lecture rather than face-to-face. And I will be providing more guidance on any remaining material in advance of the first test and on the first test in a separate communication or communications. For the moment, I'm just going to give you this lecture straight out. So this is on methods used in infancy to study babies. And one of the greatest challenges in studying babies is that we can't just ask them what they think, what they feel, what they mean. Yet what they can do is of great interest to us because we want to understand the early foundations of later competencies that we develop. So particularly, what can they perceive and what are they thinking? So perception and cognitive development are primary. Of course, there's also emotional development. There's a lot of study of social development going on in infancy, but the traditional emphases in the study of infancy have been on perception and cognition. So let's start there. One of the most important approaches used in this period is called the habituation dishabituation paradigm. You might want to say that for yourself a couple of times. It's hard to get it to roll off the tongue. So habituation and dishabituation paradigm. And basically this is using a tool that we're all familiar with, boredom. You can think of yourself watching TV. Maybe it's a show you don't like, or someone else is watching it and you're kind of stuck there. At what point do you start to sort of grab a book and read or look out the window or something like that? That's your boredom occurring because you've become habituated to something. It's no longer of interest to you. So dishabituation is actually what happens when you are broken back into attention to that event. So to habituate you, you're watching television and you're kind of losing interest, right? But something might jar you, like the volume might increase, or maybe there'd be a brighter image or some event that draws your attention going on, and then you've been dishabituated. You've been drawn back into the stimulus so that you look, watch, and listen longer. So if you do that, and you're in that re-engaged state, you're now rehabituated. You're engaged again, which is kind of paradoxical because your initial state was habituated. So the state of being ready to be bored is called habituated, or when you get it back, it's called rehabituated. And dishabituation is what brings you back. So this is very interesting in childhood because we can't just ask questions of young children. We have to rely on some other techniques. So we're relying on the infant noticing some kind of a difference. And once we notice that they're attending to something again, we have the option of measuring in very careful ways how much they're interested. For example, looking time. How long do they look at something else once they've been dishabituated? That they've seen this novel event, such as in this bullet, a triangle turned upside down. So you can imagine they're habituated to this shape. Yeah, there's a triangle. And then suddenly it does this, right? Ooh, let's watch that for a while. And how long do they watch once that's been done? And how long does it take maybe for them to look away again, right? So they've lost interest again. They've been rehabituated. This is now already a steady signal for them, and they're not interested anymore. So we need lots of ways of doing this to answer complex questions. So looking time, listening time, these are all pretty routine. But the important thing for you to realize is that this paradigm prevailed in early infancy research for a long time, and it's still very prevalent as a way of understanding, quote unquote, what kids who can't talk are thinking, or babies who can't talk are thinking. Once you have that basic idea down, you can elaborate it. So imagine that you have two things, right? Two stimuli, and I can maybe show them sequentially, right? And I can measure differentially. All right, they're more attracted to this than to that. Or I could alter them in different ways. I could say, all right, here's the triangle, we're going to flip it. How sensitive are they, though, to just a subtle turn of the triangle, right? And do they do the same thing for a circle, right? If the circle is rotated in some way or turned three-dimensionally, do they do the same thing for a circle and a triangle? So you could learn very finite things by looking at lots of babies and deciding, how well can they graduate understanding of very subtle perceptual differences, and really learned a lot about perception. Another way to do this is not looking time, but sucking time. Babies love to suck things, so pacifiers, fingers, almost foods, nipples, anything that they can suck. This is kind of baby speak, being able to show, yeah, we like that. So if you give them a pacifier, you can actually get them to associate in sort of a behaviorist way their sucking with certain stimuli, right? So you can get them to associate maybe a positive image. Let's use the triangle just to stay simple about this. Every time they see a triangle, they get the pacifier, right? To the point where, just like in Pavlov's dog, if the bell is rung, they will want to have food. They see the triangle, they want to suck. Okay? So once you have this, you've built basically a communication tool in the baby, so that when they see a difference that maybe attracts them, right? When you dishabituate them, you might find that they suddenly stop doing something. So let's say that you've given them a pacifier, they're sucking, right? And I repeat the syllable pa, 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 and I get them to dishabituate to it, right? So they're no longer, I get them to habituate to it, so they're no longer interested in it. And then suddenly I switch and I say ba instead of pa, and their sucking goes down. They're no longer sucking at the same rate. And we take that in the same way that we would take looking time. Their glance might be greater to the triangle, reflecting that they've been dishabituated to the image of the triangle turning. And in this case, they've heard the sound alternated and they suck at a different rate, at a lower rate, because they're now attending to this new sound. Or a faster rate. It depends on how it's set up. So those are important tools to understand what we actually do in research, and it's important for you to understand that when you review certain aspects of the chapter on infancy. In the textbook, it covers this, but also some of the examples. So I wanted to spend a little time with that. But let's step back now and think more generally what's going on for the infant. And so my favorite analogy about this period of life is to think of, there used to be little cartoons of pigs in space when I was a kid. So that imagine the pig is kind of flying around and flopping around in space. And it's kind of amorphous and it doesn't know what's happening to it. It can kind of bump into anything. You can think of an infant as being much like that. Of course, they're not a pig. I'm not making any suggestion of the sort, but that floating idea that they're a very sensory organism at this point. They don't have comprehension of much of anything. Everything's new, everything's novel, and they need to kind of wire up what they have with what the world brings to them. So William James, one of the earliest psychologists, described what he thought the experience of an infant must be as a blooming, buzzing confusion. Imagine you're in this new space and everything that hits you, whether it's mobiles, bottles, edges, things around the edge of a crib, pillows coming in and out, parents walking by, being held, being picked up, put down. This is very, confusing, probably, for the infant. But you have to accept the fact that infants, over generations, right, over evolutionary time, have been exposed to this confusion over and over again. So those that survived most likely have some tools that are ready to sync up with the things that you're likely to experience as an infant. And many people believe that certain reflexes are available from an innate standpoint for this exact purpose. And so you can think of, rather than having a ready-made language, right, being ready to speak, they have a ready-made set of an inventory of tools built of reflexes and sensory abilities. For example, facial expressions. Very early, infants can actually mimic facial expressions. You can go down and smile at them just like this, and you, in many cases, will get a neonatal smile back in response when you do that. You can kind of do things like this, and sometimes, especially with older babies, you can get them to kind of play along with you a little bit. So this realization on the part of researchers allowed elaboration of the dishabituation, of the habituation-dishabituation paradigm. Okay, so if you use the mixture of tools, if you assume, all right, it's not only our ability to create conditions under which they can look or gaze, but we could actually elicit an independent response from them in the form of a reflex. So some researchers by the name of Andrew Meltzoff and some of his students, more in particular, did a lot of this and came up with fascinating studies using puppets. And they basically see which reflexes are available for the babies, and they try to link up those reflexes with stimuli. So let's talk about imitation for a moment. Sometimes we think that they're repeating something, they're imitating something, be it a smile or a gesture or something, just because they can port that in to the system and do it. But it doesn't stick. It's just kind of, oh, there's that, and I'll do that too. But at some point, they begin actually enacting those reflexes into tools that they could use. Okay, so someone comes and smiles, and they generate the smile for you. So it's no longer reflexive. It's become a tool that they've incorporated into their ability to interact with the world. Recognizing others is something that babies are actually pretty good at. And they start doing this kind of early communication through facial expressions and movements very early, and they move very rapidly through it, which of course is very rewarding to parents. So I have a short video on reflexes, and I also have some personal material to share on this that's a lot of fun for me. So hopefully this will play on this format.
In the first 2 months, babies exhibit the stepping reflex. This is probably a precursor to walking. Watch Lily's toes fan out. This is the Babinski reflex. It occurs when the bottom of the baby's foot is straight. When pressure is placed on the baby's hand, you can see the grasping reflex at work. Lily's grasp is strong enough to support almost her entire body weight. For a few seconds at least. When startled or dropped, a baby may respond with the Moro reflex. The arms fling outward and inward as if the baby were groping for support. 2-month-old Julia doesn't even need to be awake to demonstrate this reflex.
Okay, so, foolish things. Don't know how to make those things stop. So, what's neat about that video, particularly the Babinski reflex, is it shows you something that we would assume had some evolutionary use. Being able to grasp maybe onto a limb or onto part of a parent, to grab, also to hang on for nourishment, for care, for warmth. These are tools that are inherent to survival. If you couldn't do that, most likely there would be some situation where you wouldn't get what you need and you may not have survived. You may longer, your genes may not be in the human race anymore. So almost all babies, unless there's some problem, can do these things, and they don't have as much kind of apparent survival use anymore because we do so many things for babies. But the idea that they have these available to them and they can modulate them into necessary feats such as walking or climbing is promising, and it would suggest that, look, if we can find other reflexes, however subtle they might be, it might be a reflexive ability to imitate a face, a facial expression, or other things, movement of the jaws. We don't really know. There could be many reflexive abilities that children have that they're enacting in order to create handholds for functioning as full-fledged adults. So a little bit more, I'm going to show you a video involving my son. I can't play this file in this format, so I will post that separately. But it basically shows you some of those reflexes and having the doctor do that with my son, just a little bit more real example. Okay, so an important question is, why would these infants have the ability to imitate? And the Meltzoff studies show that the imitation of novel acts, such as things you wouldn't expect a baby to do, like banging your head against a board, is feasible for them. So it tells us that, look, these are teachable tools. We can utilize the tendency to imitate to let the child take in abilities that we want them to take, obviously not banging your head on a board. Once we've gotten a baseline repertoire of imitation ability, sensory ability in place, this setup allows us to then expand, to differentiate our abilities in lots of domains. So it's important now to start to think about different domains of development. Until this point, we've talked only about prenatal development and then teratology, so the risks to prenatal development. Now we're talking about live babies, and domains of inquiry for babies take at least the following forms. So motor development, you're climbing, you're walking, you're grasping, those types of physical achievements. That is the domain of motor development. And there are developmental psychologists who study motor development exclusively, such as Esther Thalin, a very famous researcher. Perceptual development, the ability to what extent can we perceive and sense through all of our sensory abilities? What do we actually take in? What images are available? To what extent are they filtered through our limited vision at different points, for example? And cognitive development, what's going on mentally in response to these activities or perceptions? And of course, there's other areas which are more difficult to study in early infancy: social development, emotional development. But these are the key ones that are usually of focus. So a neat idea about motor development is, we tend to think of ourselves as humans as being superior to almost all other species. But ironically, we are among the most helpless at the time of birth among other species. Most other mammals, and certainly many other insects, are born ready for the activity that is presented to them at the time of birth. We are not. We don't have the ability to walk. We can't talk, for sure. We don't have the ability to really engage in any meaningful interaction. We don't have the ability to defend ourselves at any level. So there are questions. Why, as such a sophisticated organism, by far superior in terms of our mental capacities and our ability to do things socially than other organisms. Why is it that we would be so incapable at birth? And one theory about this is that we need that time to wire up for all the other things that we're going to do that are not like what the other organisms do. We need time to connect these reflexes, to receive stimuli that we could imitate, to build language, to do all the things that are going to make us have these advanced abilities. And to do that, we need to be kind of immobile. We need to be kind of slowed down in our development so that all of the other things can begin to progress. And that immobility will force us to be with a caregiver who can provide us with that experience. Revisiting some of the ideas that we've talked about in the past in the context of prenatal development, these ideas persist at least in early infancy. So the cephalocaudal trend, that development goes from the head down. Well, yes, we saw the organism grow out of the brain and the spinal column, and over pregnancy proliferate out to the limbs and other fine motor types of the body. That's also the case in infancy. Your mind is rapidly developing, but your attention to these distal parts of the body is not so much, right? We're not rapidly learning to walk. That's not beginning until around 9 to 15 months that we're really rapidly progressing on that dimension. Same idea, proximo-distal trend from the inside to the outside. The organism is learning to process foods, right? So that's key to being able to survive. We want the ability to use our bowels, right? So that's really fundamental organ delivery. Use our mouths for chewing, develop some teeth. All of these core things are happening first, and the ability to do more adult human-like actions is much in delay. At the same time, you could say that what's happening within is also inclusive of the brain, and that's not really like a head top to bottom or inside to outside cephalocaudal or proximal-distal pattern. This is on its own now. The central nervous system is the primary player in getting the human adult-like capacities developing, getting that underway. And a key part of that has to do with wanting something, right? We have wishes. We want affection. We want nourishment from a very, very young age, from the moment of birth almost. We want these things. And we make our intentions known by doing things like crying or rooting for the nipple or doing other things that would show interest in warmth and affection, right? Trying to form connections. So even from the very early moments, we're seeing the apparent, at least apparent, if not real, intentions of the baby emerging. Now, imagine a situation where none of this is occurring. Right? So the baby is born, and maybe the mother has passed away, and there's not a sufficient surrogate. The baby is born and placed in a care environment that might have limited staff available to provide nourishment. So early orphanage for settings for newborns tended to just undertend to the developmental needs of babies. They provided food needed to nourish, but they didn't organize themselves in terms of staff count or staff time to put in sufficient amounts of interaction with the baby, and pretty serious developmental delays have occurred. Even to this day, fortunately this is becoming somewhat lessened through the advances in science, but even in the 90s, orphanages, particularly in dictatorships such as Romania, other places like this, where large amounts of babies were left in underfunded and underserved orphanages, a lot of those babies had longer term delays, especially in language, but also in other areas. Nourishment, basic nourishment, led to problems with physical development. So if you don't have practice, that can certainly impair your development. And of course, this doesn't only have to be extreme deprivation, it could be modest deprivation. A mother who's more gregarious or a parent who's more gregarious, spending more time, having more time, not being at work but being available to the child, you can see pretty dramatic differences in the speed of development. Of course, many people believe that there's an acceptable minimum, that everyone will be fine if they receive an expectable minimum. This is an idea promoted by a researcher whose name is Sandra Scar. But I think the more important question is, what is the maximum? What if we go very, very far? We provide constant interaction and very well tailored interaction. What are the developmental possibilities? How incredibly well developed or kind of creatively developed can a human be if we optimize our knowledge for their development? The child's body. So we see certain physical developments at this time. So being able to move limbs in a way that shows that you know where they naturally land. So in early infancy, babies will move their whole arm up and it flops over their head like this because they don't really know what its range of motion is. So these all take time to develop, so you can actually reach your face and touch your face without missing. Stepping reflex, this is something that I'll share more material with you on later, but this seems to be in part innate, that we have the ability to step in a stepwise fashion innately, but it needs to be enacted. And we don't necessarily have the muscles ready to enact that in a vertical position, but it's been shown that you can enact it without having a vertical position. Little things that we rely on. This is actually one that I wonder if my daughter has this down. Even she's 5, she's a little bit injury prone. When we walk along, we're always reliant on very subtle cues from the terrain in front of us to know where to walk, how to keep our balance on certain types of terrain, along corridors or on a path, these types of things. So you can think of it as a kind of a handrail image, that there may not be a handrail there, but you're walking along as if it's there, and that kind of keeps your body centered and upright. So having the gross motor ability coupled up with perception in order to do something like that is also a developmental achievement in the gross motor domain. Okay, so if we were together, what I would do typically is blindfold someone in the room and show, once this is taken away, at least through your visual sphere, we're actually pretty bad at this. We're heavily reliant on the visual aspect for our walking. We're not using sound much at all. Only with learning blindfolded to kind of learn from your previous steps, which is a different way of ambulating, do we see people make progress. So that's the kind of thing that I've shown in classrooms, that once people learn terrain, they learn to sense out with their feet, as blind people have to do. But that, absent that developmental experience of developing the visual field and the sort of a visual rail, you wouldn't have it at all. So some people are denied that opportunity if you're forced, for example, through perhaps a critical period to remain laying down. So, of course, this could translate when you learn later into more injury. And injury itself, minor injury, is a lesson maker. My kids have taken some spills and gotten some cuts, and I remember being upset that they got hurt and mentioning it to my father, and he said, "That's just that's what people learn. I suppose you remembered me getting banged up." So, so much of what we do, we have to accept as parents and humans as being normative and needed for survival. So here is an image. I told you that you can actually induce the walking motion step ability, but that babies don't yet have the muscular strength to do so. So here's an example of them foolish. It doesn't work on this viewer again, so I'll let you play that separately. But the idea is that they can take steps when they're put on a treadmill or in a fish tank in water where the muscle demand is reduced. They can still show the stepwise gait. Excuse me. So fine motor development. It is proximal distal, right? It starts from the arms, right, and then gradually moving down to the very difficult to enact specific movements. And this can take months and months, even into the first year. And what you have here is arms to fingers, all right? So then from fingers into specific grasps, right, which we tend to think of as being nameable, although some people debate whether the names are under reconsideration right now. Maybe there are a diversity of reaches that are available. But the ulnar grasp was one of the first to develop, that you're just grasping something like this. And then over time, once you've gotten that, you can actually do it bilaterally. You can pass things from hand to hand. And then, I should say by end of the first year. Maybe I'll fix that right now. I don't know why that got in there that way. That by the end of the first year, what you see is this grasp, which for some reason is extremely difficult to develop. I guess it must have something to do with the opposable thumb, and maybe the amount of brain activity needed to rotate these fingers over to the thumb and then to aim and grab something and actually apply enough force to hold it. So there's actually quite a lot involved in doing that. So both of these grasps, as well as the ability to get babies to reach for something in particular and find it, are used in pediatric assessments on a regular basis. When they see that one of those has not developed, it raises questions. Are they having sufficient interactive time with objects and people? Or could there be something a little more worrisome going on, such as some type of developmental impairment? It could be as simple as a visual impairment, not having sufficient visual acuity to do something like that. Or it could be something cognitive, something that was impaired during the perinatal period. So these types of problems that might have been subtle and not observed through normal behavior, you might think you have a perfectly functioning young baby, but maybe only under certain specific tests does it become evident that maybe there are some deficits in play. What babies can do is actually pretty amazing. They have some parts of their system that are anticipating the use of these abilities. So it's very amazing to me. And incidentally, this is my daughter, who's now 5 here. So this is how she looked at around 2 months. At that time, she could already anticipate where to reach for something, even though she couldn't reach for it. Okay, if I pick something up, such as this coffee holder thing, coaster, if I were to throw it over there, she would know where it's going to go without question. She would look in the right place. Or if I throw it over here, she'd know to look there. And that's pretty amazing given that they've never thrown anything. So that really is a strong suggestion in my mind that there is definite genetic information that's encoded over evolutionary time to give us ready abilities that we're ready to sync up and use, even though they're latent at the time of early infancy. They take some time to practice actually grabbing for things. And one thing that's kind of fun for everyone with babies is you wave something in front of them, right, and you're 6 feet away, and maybe they see it and they're grabbing for it. Well, of course they can't reach it, right? But at some point they learn, yeah, that's too far away. I can't grab that. So it's a neat idea that they're learning things like this, and they have some ability, but it's not refined yet. That takes experience to refine it. And this same set of abilities is kind of mirrored in effect a little bit later with sound, hearing and sound. So audition later mirrors this sequence that's much more easy to identify in visual displays. Bear in mind that there are some physical constraints to doing some of these things in the visual space, and this is actually a limitation in terms of the habituation dishabituation program paradigm. So actual vision at the time of birth is very limited. Just what's needed actually to find the nipple and maybe see the mother's face. Only just here as where the baby would typically be. And that translates to visual acuity of the equivalent of 20 to 660. I mean, that's just terrible, right? 20 to 20 is what we're usually aiming at. And it takes a full 6 months for that to improve by about 80%, only to 2100, which would still require visual correction, right? A lot of visual correction. And from that point on, over the last year and a half, it incrementally improves until 2 years. It's like adult vision. But have some heart when you're playing with babies and they're trying to figure things out. Remember, it's not just that they're seeing it as you do. They're seeing it through rose-colored glasses. Quite literally, they don't have the visual acuity needed to do some of the things. And that's one of the reasons why babies really like bright objects with sharp edges, because they can see them, right? Imagine all these little things dangling in front of you that's like little blurs. That's not very interesting, right? That's not you're not gonna dishabituate from a blur. But if you give me a stark object, and even better if I could go over there and feel it, that's something I can interact with. I can have an experience. I can move it. So if you have wrong-sized, so to speak, objects, you might buy a baby toy that's a little tiny thing that they'll think is cute. Cute toys don't work for little babies. They can't see them. So, think of this. Our adult preferences are drawn in. Maybe you see something that's a few dollars cheaper and it's a small little trinket for the baby, but that's an adult trinket most likely, and not a baby trinket. Okay, it's fun to know, can babies recognize us? And the answer is yes, they can, but it takes a little while. The reasons have to do with what I just explained, in part about visual acuity. So if you're not actually seeing fine detail, it's hard to reliably find the features of a person to know who they are. Scent is actually much stronger. It seems that a baby can smell the mother's breast milk and the mother, and learn the smells of other people, and use that together with evolving or emerging visual ability. And we know something about from habituation dishabituation tests, what they're seeing, what they're calling out in order to identify. They're looking at the sharp images, so the bigness, right? So even a very young baby, if you show a big face coming at them, sometimes they're either threatened by that or they think it's very fun and appealing. I noticed that babies really didn't like my white beard, and when my children were young, I had a white beard then too, and I shaved it off because I didn't like scaring my own children. They seemed to react to the brightness, and it was different for them to see that. No problem now. So by 2 months, they can actually get into greater detail, and they have finer discrimination. So that's not very long, and they're working with very low visual acuity. So something is telling us that this is a priority for them, as you would imagine that being able to identify important others is a priority for survival and for human connection. So if you'd like to do something fun with young babies, there are lots of neat videos. I tried these with my kids, and they're so much fun to try with babies. Some of them are kind of slideshow types, as this one is. I'm showing you a set of images that you can easily find on YouTube or whatnot, and they show them sequentially, the sailboat one or the stars one, and from child to child, you'll get variability in terms of what interests them. And you can actually see that variability become more reliable if you put babies at a certain age level. So young babies, will reliably react only to the very stark and bright, broad images at a young age, and then say at 4 or 5 months, they might react more reliably to novel images, say of sailboats or curves, which they've not seen before, or things that move. So it's possible actually to come up with a really fine grain of what their understanding of what their perceptual ability is through these types of tests. Some researchers have studied face recognition, and what they did is they tested to what degree are they comfortable recognizing a real face versus a manufactured one, scribbled or expressionless. These types of like blank, monotonic images of the features without expression. And one of the neat things that emerges here, and this is something you should tuck away for general developmental understanding, is that of a U-shaped curve. U-shape means that they manifest relatively high ability at an earlier stage, and then that ability drops, like a U does. It's dissipated, and in many cases it actually disappears. Something they had before vanishes, and then it slowly reemerges again. So it's a fascinating thing. Why is it that we had something, the ability to do something, and then we let go of it and had to sort of work and wait for it to reemerge? Well, it turns out that lots of developmental things, particularly in infancy and early childhood, do this. And the theory is much like this idea that we're born helpless, that we can't actually do everything at once, right? Sometimes we fire up for something and we make a certain amount of progress, and then something else demands our attention. For example, maybe we're working on language, so for that period of time, maybe facial expression drops off a little bit. Exactly what's being dropped and added, there are researchers who know more about that than I do personally, but the idea is quite understandable, and that is that you're turning off your developmental trajectory for one sequence of developments and turning it on for another. A milestone here is that by 3 months, infants can actually recognize faces of strangers and separate faces of strangers from their mom, right? So they can choose the unknown from the known and vice versa. And you might wonder, do babies know anything about who has good looks? And they do have opinions on average about this. They prefer, on average, if you take all of the ones to which they have longer looking times over a large number of babies, they prefer average babies. They seem to have a higher preference for ones that are more identifiable. And if you think about that, it makes sense because in many things in lives, we're looking for patterns and trends that are useful to us. So what is a pine tree? I need to know that it's reliably the one that's green. But if it's not quite green enough, it should be the one that has needles. And if it's not quite needly enough, it should be the one that's there in the winter, right? I'm going to put together all these multivariate observations of a tree and average them to know that it's a tree, right? So you would want to do the same thing with humans so that you could distribute people around some mean. So you could decide that attractiveness is a deviation from a mean, right? So it's not actually fair to say it's attractiveness. It's more like they have a preference for looking at that average face because they probably need it. And based on developing that understanding of a baseline human, so to speak, they would then depart for identification, for attraction, for use, basically. Where are the deviates? So it's actually the deviates from the average, the abstract average, that are useful to them, but they need that center to start with. Okay, so what about objects? What about things being in the world or not? Because lots of objects for infants are ephemeral. So this is the idea of object perception or object permanence. So this is of great interest to Piaget, whom we'll talk about in a different lecture in greater detail. In this lecture, we're just talking about the basic ability for things to exist at all, right? We're like basic perception. So they think things are real, but when they're closer, they actually look very small to them, and it takes time for them to understand the bigness kind of trajectory, that distance and size are variable, kind of like a telescope, like a moving a telescope kind of a thing. It takes time for them to graduate that and develop that into a reliable use of size. Um, they do understand that once they've identified the size of something, that those sizes are not malleable, and they actually do get surprised when things grow or shrink like that unexpectedly. So that seems to be kind of a hardwired thing, this idea that things should be fixed. It's possible for things to be fixed. What can infants hear? We talked a little about what they can see in terms of size. This is also a U-shaped curve kind of thing. So they seem to have a lot of pre-wiring on this as well. So around 2 to 3 months, they are good at knowing where a sound came from. So across the room, boom, they can look in that place and seem to know where that came from. But surprisingly, it was at newborn time they're good at that, and then at 2 to 3 months it goes down, and then it comes back at 4 months. Strangely, so what is it that we're doing while that goes away and comes back? I don't know. Probably some other developmental achievements invariably are being achieved. And then it takes longer for them to actually be able to know when to reach for things, which would connote some amount of understanding of distance. So by 6 months or so, they know not to reach for toys that they can hear as being too far away to reach. Infants are kind of ready absorbers of sounds, and from a very young age they can automatically tell the difference between basic sounds. We'll talk about what those sounds are another time. But pa, ga, ma, na, they can discriminate those very quickly, very early in life. And you can think of language as including all the sounds, right? Noise, basically, is what you start with. And the infant is open to all sounds. And what they're doing very quickly in life is selecting sounds that are sounds of language, not cars and balls and buildings and so forth making noises. They're selecting that into language, and even more precisely, from a very early age, they're selecting sounds of the dominant language to which they're exposed into their hearing and reproduction system. So this is one of the reasons why babies seem to prefer so-called motherese. You could also call it parentese if you want to be more egalitarian about this. But the nickname for this is motherese. It's this slow, sing-songy kind of voice that mothers use with their kids. So, do you want to play with the toy? Do you want to play with the toy? Oh, the toy. Here's the toy, right? This type of speech is what mothers find attracts infants, and the theory behind it in terms of what's happening with the child is they're developing the ability to follow intonation and derive meaning from intonation, on which they later sort of hang the parts of speech, so that they're looking for a noun at the end of a question, or they're looking for an interrogative word at the beginning of a question. They begin to hang those on there and figure out that those are words that get you answers to questions, such as why. Why? Okay. Finally, voices. Using the idea of conditioning, the ideas of conditioning or habituation, the habituation dishabituation paradigm, excuse me, it's been shown that very, very young infants will suck longer when they hear the mother's voice than the voice of another female. So how is that possible? Well, it's possible that they heard the voice in the first 3 days, but that doesn't seem very plausible. Most likely there is some exposure to the tones of the mother's voice, or maybe the rhythm of the mother's voice happening prior to birth. And this is a very hot area of research, has been for the last decade or so. There have been studies indicating that they prefer mothers reading a story to another, and they also prefer that a story, in particular story, that the mother read in utero while the child was in utero to other stories. So that's very informative. That if they actually know the story, so to speak, they must have been picking up the rhythm of intonation, and somehow they're associating the tones and the sounds with the mother's voice. Okay, that's enough for now, and I will be in touch about other demands